EPLANT-Piping Advanced tutorial. This presentation shows how to load a piping specification. In our example, we are going to show how to load this class, here defined in Excel format. We have the definition of pipes, fittings, flanges, studs and gaskets. We have the branch table also, and valves. We need to codify each specific component that corresponds to these generic definitions. To begin with, we add 4 new columns where we are going to write down the EPLANT codes and use afterward this information to load the class. We start with the pipes. We open the EPLANT component codes report sorted by description. The previous video shows how to generate this and the other 2 similar reports that we are going to use in this presentation. We search the pipe by description and we get in this way the PIP code, which we write in the first column. We look for the material associated to this pipe in the material code report. The corresponding EPLANT material code is CC2. We have now to translate the plain end. We need the EPLANT end codes report to look for that end type. The corresponding code is PL. The second end is left blank because it is the same as the end one. For 2 inches and greater, the pipe material is the same. It has beveled ends that translate to BE, which is compatible with the BW code that will be used for all fittings butt welded. Let's see now the fittings. We have to open this generic group to specify each one of them with its code. We'll begin with a 45-degree elbow. We can see 2 codes with the same description. In this case, we select the 45E. We look for the material. The corresponding code is CM1. We need the end code for socket weld, which is SW. We select the 45E code, but the 45B could also be used because it has the same generic description and also because, being this class according to ANSI ASM standards, we see that both codes have the corresponding dimensional tables, at least for threaded and socket. A different case arises with 90-degree elbows. For socket weld, we have to use the 90B code that has the generic description 90 degrees elbow. The 90E code corresponds to long radio and will be used for butt welding. In this way, we identify other required fittings as well. The last code, RHC, half coupling for reduction, is specifically used in branches. It must not be confused with the HCP that it is used when the coupling is connected to a pipe end. By applying similar criteria, 2 inches and above fittings are those written in the worksheet. In case of flanges, different connection type for the side not flanged corresponds to a different flange code for all flanges, and 1 is the flange 1 always. All flanges, but the blind one, require the specification of the end 2. In this case, is socket weld. For the slip-on flange, the butt weld type connection is conventionally adopted for compatibility. With the same criteria, all other components are defined: studs and gaskets. Let's see now the valves. This one is a socket weld check valve. The same but RF flanged. In this case, the code has to be changed because the type is a wafer check. And in the same way, the other valves. Valves operators are specified using their specific code, for example, a hand wheel or a gear operator. We can start now loading this information into EPLANT. We open our project from the database module and select Piping Specifications. At this moment, we do not have any class defined. We can load it a line at a time from this edit window pressing the keys Ctrl Y or importing an Excel file. Let's see first loading from this window. We start loading piping definitions using the codification we just happened to do. When changing line, all fields are checked, and this warning says that the upper range of the diameter range cannot be void. Actually, it is because we mistook the columns. Trying to load a new line with Ctrl Y, the command realizes that the additional codes table is void. Given that in our line we did not specify the code value, the command prompts whether or not to add the blank value to the table as a valid code. We need to split into two lines for bevelly end pipes, because above 12 inches there is a schedule change. We load now the 45 socket weld elbow. The socket weld flange, the gate valve and its operator that is specified in the OPE column. The valve code, which we are loading as additional code, is not defined in the corresponding table, but we can automatically load it by setting this option. The same as we have already seen for the blank code. We close this table. We look now at the additional codes that were automatically loaded. We see the two that were just created. The first one is the blank value and the second one is the valve code. With a double click here, the edit window opens. We can associate in this way any arbitrary definition to each additional code. The descriptions are available to be automatically placed in material reports. We can also add a short description that may be used as reference. We go now to the branch table. The table is void. Let's see its definition in the specifications. Here we see the EPLANT codes. We begin loading it line by line.